Hello all, and Merry Christmas if you celebrate. Welcome to update number 7 of the Zig-Clr project. So I've built a lot of things since the last update. I said that I wasn't going to implement null safety for Zig-Clr, but I changed my mind because it was so easy, and Claude was able to knock it out in about a day with almost no intervention. So what null safety is if you have an optional variable and you access it with the dot question mark, that is a checked in release modes null unwrap. But it's supposed to panic if you don't have if you do have a null value in there. What Zig-Clr is able to do now is to track the state of an optional, and if it's known to be null or if it is suspected to be null, then it will warn you that you shouldn't be using the crashing form of the null unwrap. I've also implemented structs and unions, which turned out to be pretty similar. So once I had finished structs and fixed a bunch of things with structs, unions were relatively easy for Claude to figure out. So let me go ahead and demonstrate to you some of the struct stuff. In this case, this is the composition of structs with allocator checking. So in this case, it's a use after free. So let's step through the program. We're going to create an allocator, that being the page allocator. We're going to create this container. The container simply contains one pointer. So this is a pointer to U8. Then we're going to allocate the memory, and then we are going to set the value to a number. Then we're going to free it in this function here, and then do a use after free. So because the callee has already been freed, we shouldn't be able to dereference this pointer. Okay, so let's run it. And we can see here it says there was a use after free in the main function line 21. That's the use after free right there, line 21. And then it tells us that container.pointer was freed in passed to callee use after free.free container. That is on line 8. So let's go there. There you go. And it was allocated on line 15, which is all of the information that you would want to know to be able to debug this. Well, not all of it, but a good chunk of the information that you would want to know. And it even is able to tell you the variable name and the field name. So in this case, container.pointer. The other thing I want to show you is this wrong variant after change. So I did implement unions, and unions should have the undefined safety and also the allocator safety that I just demonstrated, but for structs. But one thing that is different between structs and unions is that unions can actually have only one active field at a time. So let's step through this code. In this code, we have this union called value. It is set to the int part of the union, which stores an int32. It can also be a float. So in line 2, we clobber the int value and place a float value in there. And then we attempt to access .int when .float is now active. So this is a assertive union value access. If it doesn't actually have int as the active form, Zig will crash or have undefined behavior in non-safe releases. So we want to be checking this. If you want safe access for this, you want to use a switch statement. But note that in this case, this is not a tagged union. So you won't even be able to do a switch statement in this case. So you just need to be able to keep track of what is what. And there'll be some cases where you may do an if statement. If you do this, then it stores an int. If you do this, it stores a float. And CLR will maybe fundamentally not be able to keep track of those things. And so you'll have to assert that it is the correct choice via some other mechanism, assuming that you have stored the choice in some other form. But in general, it's considered to be bad practice in Zig to use an untagged enum. But also important to note that this will work for both tagged and untagged unions. So I'll show you that in a moment. Okay, so let's go ahead and run this. And you can see it says access of inactive union variant int in wrong variant after change.main. So that's in the main function on line 10. And the active variant float was set on line 8. So it kept track of the fact that as it passed through this code, it switched from int to float, and then it attempted to access it. So I want to show you that this works equally with like tagged unions. And you can see it produces exactly the same error message as before. So what's next? Next, I'm going to be implementing field parent pointer, which is a very Zig specific type of safety. Namely, if you attempt to use field parent pointer with the wrong type, it should give you an error. So that's what's up next for me. And then after that, I think I need to do switch statements. And then I'm going to attempt to do loops, which is probably going to be one of the harder things. And hopefully this won't drag in too much into January. But the thing that I need to tackle beyond that is ownership. So what happens if you give a pointer to another object that needs to keep ownership of it in the Rust sense? And then also after that, I probably need to figure out how to do global variables and global pointers. Okay, that's what I got. Like and subscribe. And if you want to support me in this last couple of weeks that I'll be doing this, I'll put a buy me a coffee in the link below. Thanks.